and very accomplished alumni, has kindly agreed to also moderate this masterclass and discussion. So I'll quickly first start with a brief introduction of Sushil, our moderator for the day. So Sushil has about 30 years of experience in working on issues related to NRM, climate change, and conservation. He has delivered many excellent programs, projects, and research in this area in India and worldwide. He has completed 3 masters. After IFM, he went and did a MSc from Oxford on forestry, and then an MPhil from University of Cambridge. He has many very highly ranked publications to his credit. He was a Gates Scholar at Cambridge and holds a PhD also from the University's Department of Geography. Sushil now works and oversees the conservation and land portfolio for the Nature Conservancy in India. The TNC, as you know, is one of the world's largest, if not the largest, conservation institute. And Sushil is leading a lot of their work in India. So, very warm welcome, Sushil, and thank you so much for agreeing to moderate this session. Now I'll turn to our other equally accomplished alumni, whom we all know very well, who is going to deliver the masterclass. Alark. Alark, firstly, welcome and thank you so much. Good to see you. Alark is an assistant professor at the School of Forestry at Northern Arizona University. Alark is a true forester at heart. He uses system thinking approaches to environmental problem solving. He focuses on issues of climate, poverty alleviation, environmental transformation. After IFM, he went and graduated from the Yale School of Environment. He's also taught at Yale National School of Singapore, and he's given lectures in many prestigious universities around the world, including Columbia, Michigan, IIT Mumbai, FAO, World Bank, etc. Alark hails from Bhopal. He lives in Flagstaff in the US with his wife, Dr. Alder Saxena, who's also a professor of anthropology, and his 2 kids. Besides being an avid forester, I also know that Alark is an adventurous traveler. He's also a black belt in karate and is working towards his private pilot license, amongst many other things. So with that, I'll hand over to now Sushil to take over the moderation of this session, who will give us instructions and thoughts on how he would like to conduct the session, and post which he'll then invite Alark. Thank you very much, both of you, and I hope we have a great session today.
Thank you, Swapn, for your kind words and introductions. So actually, as you all know, that today we have this masterclass which is led by our own alumni Alark. So the title you all know is Systems Thinking Approach to Problem Solving. So essentially, the way it is structured is that there are 2 broad objectives of this session. That first is to have some understanding of the theory and evolution of the systems thinking. That will be the first part of the session. And then the second part is the application of that. How do we apply this concept for problem solving, particularly for environmental problems that many of the alumni work on. But it's not limited to environmental problems. This thinking can be applied in any field whatsoever. So the broad structure is that we'll have this theory with a focus on sort of the evolution, and then on the social ecological systems and the complex adaptive systems. This will be for the first 15-20 minutes. Then we will just pause and reflect a bit. So if anybody has any questions or any pressing sort of clarifications, that people can put in the chat while Alark is speaking, and I will keep an eye out for all those messages. And then we'll have a 5-minute or 5 to 10 minute sort of discussion when we transition from the theory then to the next part, which will be the problem solving part. There will be some I think Alark has planned some hand-on exercises, and he's put some link for that you can see for the polls, etc. also. So then that session will be done, and that again will be for about 15-20 minutes. We'll see how it goes, and then at the end we will have a sort of a general reflection session and an open house discussion. So just to lay some ground rules for the session, while Alark is speaking, I would suggest that everybody puts their mics on mute. And if there are any questions or thoughts that come to your mind, but for the theory bit initially, then you put it in the chat. And even later on, you can put it in the chat, but then you will also have an opportunity towards the end to kind of have an open sort of discussion with Alark. So that's the broad structure. So then without much ado, I'll just hand it over to Alark to take it forward from here.
Thank you so much, Sushil, and it's such an honor. It's always a pleasure, and as Swapan said, it makes it even better when illustrious alumni like Sushil and I see our alumni Jose PD is also here, many others. So very happy to be here, but also makes me a little bit nervous of how I have to perform now in the next hour, 15 minutes. But thank you once again. And it's such an honor once again to be part of this amazing masterclass series. I think that's a great idea. Um, on the screen, you see the topic of systems thinking and its approach to problem solving. This is a course that I have developed over several years while teaching at Yale, Aarhus University, and Yale NUS, and now here at NAU. So it's a mix of many things which I have personally studied in my own dissertation, but also at MIT, where I was working with in the Complex Systems Institute. But really tailored it to natural resource management. Before I say anything, I want to also say that if it would be very naive of me to say that one can become you will learn everything about problem solving within this 1 hour, 15-minute session. However, by definition, I'm quite ambitious and in that sense. So I want to make sure that if you have gotten up on a Sunday and decided to listen to this talk and see, then I want to give you both the theory and the practice, and hopefully have at least a launching pad from where you can get this course on. So let's see. Generally, this is kind of my approach: 10 to 15 minutes of logistics and introduction, which we have already gone through. I'll probably take a little bit more than 15 minutes if I can for theory. And then we'll try to dive in a little bit more in the operationalizing session. I would really encourage you to sign in from the pollev.com. If anybody, if you're listening from a laptop, just use your cell phone to go into www.pollev.com and type in Alark Saxena 905 for some polling information. So thank you, Amrita, for putting that information again. If you could just go to that, that would be great. Here is what I wanted planning to do: some introduction on the foundations of systems thinking, take some icebreaker, doing some polling activity, and we'll see if everybody's able to jump in, then awesome. If not, then I'll probably save the time for discussion. Sushil, would you just give me a thumbs up that the screen transition is happening appropriately for you? Perfect, thank you. So this is going to be my strategy, which everybody says do not present like this, but I think my ambition is going to make me take these slides. So death by PowerPoint and learning through the fire hose is going to be the nature of today's presentation. I wanted to start with this. This is a picture of me as a young IFM graduate, 2002, going to Kotra region in Rajasthan to do a baseline watershed study. I wish I could look at everybody and ask the question, how many people are in this Jeep right now? But I'll save you the trouble. There are 30 people. And this really inviting driver wanted me to sit right next to him in the front seat. And I decided to actually climb up, because if the Jeep toppled, I'd at least be able to escape rolling out of the Jeep rather than tumbling inside the Jeep. So that was my start of my forestry career. And then right after that, I was kind of working with the Madhya Pradesh Forest Department in Balaghat region, which is in MP, for those who may not know. But it also happened to be kind of the Naxalite affected area. There you go. Somebody's saying 45 in the max count. Awesome. So very quickly, I realized that management of forest was not just about trees. Of course, IFM gave us, but also it was one of those things which I realized, I think I need to know a lot more than just simply 2 years of studies before I could really engage in it. So that's really been my journey. But now I'm a social ecologist, and you'll see this image again and again, but I'm a social ecologist. I use basically these principles of social ecology, where human and nature are part of one system, interconnected and embedded in larger systems. A quick reflection on some of the things that I'm doing right now. One of them is, post-COVID, when India experienced one of the largest return migration from urban to rural areas. how did people survive? Did forest help? If forest helped, did the forest change? If the forest change, what does it mean for future crises? This is a Swedish research grant. Another idea is when displaced populations like refugees, here in this case of Tibetans in the 60s, were pushed out of their landscapes and they ended up living in India, many of them in subtropical regions. How did they survive? How did the environment help them or not? And how did they change the environment? What does it mean for global policies for these refugees then? Another example where these concepts of systems thinking, social ecology, all are being played. And finally, I'm very happy to work with the indigenous nations here in the United States in the Southwest, working with the Navajo Nation and the Apache members about how do you include indigenous knowledge in modern science to create resilience on their traditional systems. Again, actually using quite a bit of systems thinking. All right, let's see if we try this. If this works, it would be wonderful. Can you go to polev.com and then enter Alark Saxena 905, all one word, and see if you all are there. I really hope you can. And so just for another 10 seconds, I'm going to keep this information up, and then I will go to the next slide. Let's see if you can go. And by the way, if you haven't been able to, there should be a QR code on the next screen. For 1 minute, could you say, how are you guys doing today? It's locked here, unlocked. There you are. Great. I see happy faces. See, I should share this survey with everybody who's doing these world reports on happiness and showing that people in India are not that happy. Look at this. It's 100% result of everybody who's participated is happy on a Sunday. Wonderful. For those who are able to participate, please keep that web page alive because I'm going to ask next questions on this. Wonderful. So hang in there. All right. 14 seconds. I think I'm not getting any more. Everybody's happy, which is a great sign for a presenter. I'm going to move forward to the next question. Let's see. Can you click on where are you attending today's lecture from? Oh my gosh, look at that. Somebody in the Northeast. Hooray. Well, I think we can certainly say that we have covered the North and the South and the East and the West. Folks in the middle may be still waking up. Very good. All right, thank you for participating on that. Let's move to the next slide. Would you also share with me your work experience? Sorry, Rohit, I think we moved on to the next one. If you could participate in the other one. And good to have you. Wonderful. Oh, gosh. All right. So
I think Rohit is saying poll is not opening. So I think you just have to put it manually, his name, like Alark Saxena 905. There. I think it will work.
Or use the QR code if you can. Right, so there's a decent number of people who have spent a good amount of 15 plus years of work experience and followed by, so that's a fairly good broad kind of spread. That's wonderful. And I hope that you all will have the ability to, or will not ability, but you'll gain something interesting in this presentation. But thank you. And one more, I will say, next slide, is in quick, short few words, what is a system in your perception, in your idea? You will not be graded. You can write. It's a 30,000 foot view of everything combined, interconnectedness. All right. Uh, different kind of groups coming together. Again, the word interconnected, very important, very good. Different technologies, institutions combining together, different structures and actors, diverse structures and groups coming together. Sometimes you literally have to say everything. There you are, interdependence, interconnectedness. These are the keywords that are coming out. Very good, very good. All right. So this is great. I mean, I think if you are interested in listening to this, anyways, this is pretty good. And I see that, there's a wonderful kind of set of words that you are kind of making as a word cloud. But in many, many ways, this is exactly what it is, right? A system is an interconnected idea of different components put together in a systematic way. It gives you a holistic view at the 30,000 foot view. It allows us to think about what's the integration, what's the process or mechanisms, and it allows for different groups of people to work together. Fantastic. And that's a great start for our discussion today. Okay. Whoops. Went back. I'm going to move forward if I can. There you go. Now I want to do something important, because if I created this particular series of slides thinking one thing in mind. If this is the only time you would ever take anything theory about systems, then I want to make sure that your Sunday is well spent. So the next few slides would basically be talking about creating an argument of, is systems thinking this big buzzword that's going to fade away? Or is there really a systematic case for systems thinking? And I'm going to start with this, because this is it starts with foundation. This is Gro Harlem Brundtland. Most of us, whatever we are doing today, and fortunately, unfortunately, is because of this person and the Brundtland Commission report that came out around sustainable development, right? But in her comment, you see that even if you want to discuss an issue about environment, you cannot do it without the sense of poverty and the broader issues of inequality. Fast forward, we get this Brundtland Commission report that, of course, you all have heard about. It's meeting the needs of the present without, compromising the ability of the future generations to meet. But remember, this tension of poverty and environment and how do you meet current needs with forward requires a different and interesting way of thinking. Now, some of these slides, by the way, would be redundant for you, but I think it's good for you to walk through this. This famous diagram of the three overlapping spheres of economic, social, and ecological is what sustainable development came to be. Three aspects put together that led to the Millennium Development Goals of the 2008 Development Goals, and finally, it also led to the 15 or 17 Sustainable Development Goals of 2015. But this idea has been debated heavily, and for a long time, this idea of what is sustainable development was criticized, because both, as I would say, while the idea is the integration of ecological, social, and economic aspects of development put together, the use of sustainable development definition became such that both industries and governments use this idea of sustainable development without really actually acting upon the real meaning of it. So that criticism led to a change that we must start focusing not just on this idea of spheres of development, but the interactions between the three different spheres, right? Focus on the process of how social connects to economic, how economic connects to ecology, how ecology connects to social, right? So focus on this integration, focus on the action. So you're not just simply saying this is a big goal, but what are the actions that we can take? So it becomes a process-oriented, action-oriented idea. Hang in there with me. I'm coming to systems thinking just yet, but I think it's important for us to know that this idea of action orientation, focus on the process, forced people to move on to something that we need different, right? We need to think about the idea of sustainability. Think about the creativity, moving from sustainable development to sustainability. Not too much creativity there, but the focus here suddenly changed into the dynamic interaction between the spheres, right? This idea of dynamic interaction and the recognition that the world, these three spheres of social, ecological, economic, all have these foundational complexity, long lag times of interactions and what happens, and then non-linearity, which means hard to predict behaviors, led to a kind of desire to think about sustainability, science to focus in a certainly different way. So hopefully I'm not too abstract right now still, these are bigger words, but this is the idea then, that when you are engaging then with sustainability science, we must think about new methods, new approaches that are outside the traditional disciplines. How do you do that? Well, synthesizing qualitative and quantitative informations across different disciplines. Beyond the traditional scholarship, trying to integrate these scholarships. And more importantly, place or enterprise based, which means you can't just think about a vague idea. Sustainability requires it to be applied in a place, at a time, in a given context. So all of these becomes really, really important. And so then sustainability science, how does it do it? If it needs to go beyond these traditional disciplines, if it needs to synthesize all this information and needs to be placed in context based, then it needs to focus on this dynamic kind of dynamic understanding of how humans and environment are coupling together. That became a focus of sustainability science. Problem solving, this is the topic of today's class, became the direct focus of sustainability science. It needed to focus on this idea of practical protection of Earth's life support systems so that it can meet urgent human needs, and it has to do it in a way that it is in the same place doing all of these things in one way. So what would you do? Essentially, the idea then is that we have to challenge, the challenge becomes that you have to move beyond the traditional disciplines, and you need to figure out how can we create these relationships between these social, ecological, and other spheres of theory and practice. Okay, so I'm going to pause here to see if Sushil has any comments, or if he sees anything has popped up in the comment section.
Not right now. I think we can continue.
Perfect. So important thing is that I wanted to create this idea that from this idea of sustainable development and sustainable development goals comes out a deep desire to create interdisciplinarity, comes out a deep desire to create a approach that allows for looking at processes and that is action oriented. This is where systems thinking and system studies becomes crucial, because it is the place which basically enabled sustainability science to do the things that it needed to focus on. So this is now the introduction to systems and systems thinking. These are the broad questions that I would like to carry in terms of what are systems, what's the classification. Again, if this is the only class, you can take this and these slides would actually make you very well conversant in your future prospects, right? Okay. All right, here we are, start. So if you think about it, the word systems is not even new. Systema as a Greek word has been there for a long time, but it essentially says a whole compounded of several parts or members, right? If the Oxford English Dictionary's idea is a whole composed of parts in an orderly arrangement according to some scheme. The images that you see are examples across the scale, right? From a solar system to a digestive system to a simple plane, a toy plane, all can be defined as systems because there is an organization and a systematic order in which all parts are put together. Now, I just wanted to put this, I just wanted to bring this slide. This is a website that's showing that the first time, actually, this is a bibliography from Greek kind of work. The word system is already mentioned in 1600s, right? And so it's not new. What I'm saying is not new, but it is kind of the resurgence of some of these concepts that's important. But for our purpose, I wanted to bring this forward that there was a huge push by World War I, World War II about trying to find a unifying theory that worked across social sciences and ecological sciences, heavily criticized. People were really upset about why one discipline, one group of people are trying to impose a theory on every other discipline. but there was this deep desire that maybe there are ways in which different disciplines can still talk to each other. And so Carl Ludwig von Bertalanffy, I had to repeat his name several times even to pronounce him clearly, but Bertalanffy was the systems engineer who was really looking for a general systems theory. The idea that simple principles used in one place can still be applied to other places. And that led to a rapid development of several kind of evolution of systems thinking. So here it is. We have the different cases of systems. So I'll stop here quickly and say that fast forward, there is this idea of differentiating systems in a diverse way. You can classify them: isolated, closed, open, right? Isolated, no energy transfer, no material transfer. Closed, energy transfer possible. Open systems, mass and energy both transfer possible. Now, jumping on, in this classification, what I want to tell you is that there are two kinds of systems: simple system, easily manageable, understandable, and complex systems, which is hard to explain, hard to predict because of the issues of nonlinearity and self-organization. Okay, here is a quick diagram of simple systems: a water tank, water coming in, using, water going out, or your financial system: money coming in, being used, money going out. You can understand, explain it. Here in the diagram is a diagram to show you a world's food system, a global food system, embedded issues of ecology, transportation, technology, energy, name it, right? Highly complex, highly dynamic. This is just a general kind of idea that when we're talking about complexity, the idea is that, I'll just use one of the quotes, not all. Like, I have yet to see a problem, a real world problem, however complicated, which when you look at it from a right way becomes even more complicated. The idea that we are dealing basically here is that whenever we are looking at real world problems, they're actually very complex. And the key here is to keep that in mind, the complex word. All right, so I'm kind of rapidly taking you from one side to the other. So Carl Ludwig Bertalanffy is important. We're dealing with simple or complex systems, but from theoretical perspective, there is an evolution of how systems theory has evolved. One, the functionalist theory. Society is divided in different parts. They come together, and when they come together, that becomes a whole. Kind of neatly coined with this kind of, if you have seen Kung Fu Panda, Mr. Ping talks, we all have our place in the world. Mine is here to make this, noodles, and yours is, and so on and so forth, right? Very structural idea of how a system is in the world, right? Everybody has their own place and we come together to work. But this was challenged into another second phase of thinking, systems thinking and classification, the interpretive phase, which argued that a system is more than the sum of its parts. Very important, actually, from a physics perspective. And second, that we are interpreting the world and creating a system, which means it depends upon us of what the system is. And it broke open this idea of what exactly is a system, that there is no hard and fast rule of how you can articulate one system over the other. It is your interpretation and you get to do it. Okay. And then the third phase is the complex systems thinking, which is kind of the key push that I would like to bring to you, about the idea that things are super connected and they're highly dynamic. Now, the social ecological systems approach that I use, where humans and ecology are connected, are by definition complex systems. Now, complex systems thinking emerged as a principles, emerged out of the principles of quantum mechanics, and I'll talk about it a little bit. But basically recognizing that the systems are highly dynamic and they can change their way and change their outputs even with the same system components are put together. They can have multiple outputs, right? And so the complex systems thinking articulated a few important things that we're seeing across the real world. First is emergence, which means novel patterns coming out constantly across social, across biophysical world. Non-linearity, which means the same system is behaving in different ways, so hard to predict. and then scalar issues that we are all embedded across from local to regional to global systems. So in this idea, what we are doing here is we are trying to think about how can we engage with complex systems thinking, right? And the foundational, I think if you want to take one key thing from this theoretical slide, is that complex systems thinking started to challenge the traditional paradigm that equilibriums are possible, right? That future can be controlled and predicted easily, or that we can constantly plan, and as long as we plan well, that the desired result will always happen. And complex systems thinking said, no, it is a constantly evolving and dynamic system, which means you cannot have that set of confidence. Okay? All right. Here is a quick diagram from a perspective of what is really complex when we talk about it. Now, this is an image of the Piper Cherokee, which is a plane that I'm flying. And these are the parts that have to be put together. The image clearly shows an amazing number of parts that need to be put together. Complex that way. But once the system is put together, it is very clear how the system will perform, right? That's engineering, beautiful engineering. You can predict exactly. But that is not true for real world systems, because here is the idea of nonlinearity. The same bacterial growth within well, let me just take the left graph here. What is nonlinearity? If you think about it from solving an integral or algebraic equation, it's, the result is always plus, y is equal to, if you solve for x, x will always have a plus or a minus of the number, which means the same equation can have two different results. Essentially saying the same system can come into two different phases, as shown here in this bacterial growth growing in a petri dish with amount of food. Second quality for complex systems, which is an important aspect, self-organization. Small, simple rules followed by individual system components create an interesting pattern. They self-organize, right? Small system, self-determined assembling of elements of a system, self-organization. And these self-organization leading to interesting emergent properties, like on the right side, a termite mound. On the left side, the pattern of sand across the beach. All of these, because of self-organization and unique patterns formation, is called emergence. Now, I know that I've given you pretty dense information, but this idea of emergence is very central to the systems thinking as we are thinking about it, kind of pushing the edge of science here. These are just quick examples of idea of emergence found across different places or different systems of the world, right? Left is the tunnel formation of a school of fish trying to run away from a seal, right? So the idea is simply trying to anonymize themselves, and you create this really interesting tunnel. On the top right side is the emergence of slums. Poor governance, lack of land or expensive land, low capacity, and so on and so forth, leading to its emergence of slum. What I'm trying to say here is, from a complex systems perspective, that you will see these things around yourself constantly. Now, to make this a little more tangible, here is a place where I worked in central India. These are the 6 villages that I worked in called Pipalia Goli Panchayat. This is how the landscape looks. And I'm going to just quickly move through these slides to show that from that perspective of complex systems thinking, first is the embeddedness. This village, if I can zoom out, it is situated in this area, which is very close to the Narmada Valley, right? Close to Abdullahganj in Bhopal. And it's situated in a broad network of train tracks and railroads and so on and so forth. It's also embedded inside a larger administrative system called the Raisen district. It's further embedded inside a larger ecological zone and also a even larger kind of subcontinent level biophysical system. Suggesting that even though I was working only in 6 places, this system that I'm looking at has several scales that influences it. And I need to know that these are going to affect it. And this real world system is also changing. And now this is another slide, and this, I promise you, this would be the final kind of theoretical slide, that these systems are not just static. These systems are changing, adapting to information, and evolving. And so the world that we live in is constantly changing here. This is the village again here. If I can share my arrow here, this is the village. Look at this area. Within my dissertation research time, this landscape changed from, look at the central river that's going around here. The adaptive behavior was such that by the time I finished my analysis, the village had already constructed a big dam, suggesting that these systems, the real world systems, and the classification of these systems, when we're talking about it, when we are trying to do problem solving and systems thinking, the systems that we're dealing with are not only complex, embedded, but they are complex and adaptive in nature, which means they're evolving and showing emergence of newer forms constantly. All right. Anybody? So that was a kind of a fire hose way of showing a bunch of theoretical concepts to you. I'm curious, what did you take away from the sustainability and systems thinking? Anything that jumps out? Or have I put you to sleep on Sunday?
No, maybe I'll start, and then others can also, come in. It's a great, overview that you have given. So on the sustainability, and particularly you referred to, the Brundtland Commission report and all. What, it's very interesting that it is such a fuzzy definition, but that galvanized so many people. And we had the Rio conference and the whole thing after that. So maybe I think at one level, I feel that the fuzziness actually helped at that point, because different people could, come in and say, yes, we can have a win-win, which otherwise was very challenging. So maybe I think there's something about that initial fuzziness that actually, initially led to some collaborations, or at least coming together. And then later on, obviously, when people went deeper, then all the issues that you've mentioned, came to fore. So that's just
that's
one
a good point.
Comment I had, because here, like, people could come together, like people could say that economic development and ecology are not, they can happen,
right,
hand in hand, which it allows people then to start working together. I think that was a sort of an important aspect, that fuzziness itself at that point.
That's actually a very nice perspective. I completely agree. I think the point you're saying is that it gave, it was already quite kind of, there was a lot of contention even when this definition was being brought out, and you probably are well aware of it. But it gave them the starting point, and I think that was the right thing to happen. At least people came together to agree on something. And of course, you can criticize it, but the point was that enabled people to kind of start working together. So I really like that point. Good.
Right.
And I see a lot of good responses coming in. Wonderful. Topic that has evolved due to our exceptions towards the notion that we aren't capable of perfect controlling everything. Good. Sustainable device, something that can be best addressed through systems thinking. Good. Flow of information initiates a change in system. Good. Okay. I like that idea of emergence, adaptive response, flow of information. These are all good words. Now, that was a lot of theory, a little bit more on the hands-on kind of like nuts and bolts of what is the systems thinking. So bear with me just for a few more slides, and I think then we will dive into kind of the hands-on exercise.
Yeah.
All right.
So just
sorry,
one more point. Sorry, Alark, like I want to flag here. So obviously we are today, the focus is on systems, theory, systems thinking, which is very important. Like, how do you see the whole picture rather than the parts? But just want to flag that, it may not always be either or. I mean, either or, in the sense that in some cases you do need that analytical reductionist approach also to understand the part very well, and then take a step back and understand the whole. So just wanted to flag that in some cases you do need to understand the parts also in depth, and while you keep the broader overall sort of picture in view.
I think that's a great point, and I would probably even add to what you're saying, that the systems thinking does not reject or replace the analytical reductionist approach. The system thinking enables how different sets of analytical approaches that may be working in their own discipline, how can they join hands together? And I think that's an important key. It's like it, and I do see that there can be a nervousness about, it was like, I've done only economics, and does it mean that my whole work is of no use? Or I've just done ecology, does it mean no use? No. In fact, it actually provides a very clear platform where an economist and an ecologist can know how their work connects to each other. I think that's I would say is a way to put system thinking. Yeah, thank you. But that's a great point. So some key points from my perspective: if you're dealing with sustainability, you are essentially doing problem solving right away. If you're doing problem solving, inherently it is place-based and issue-based, and it requires integration across not a discipline, but several disciplines. And to that level, system thinking enables that aspect. And this is why there is a solid argument for systems thinking becoming the platform for analysis for sustainability sciences. Okay, so it's not a buzzword, it's not a fad. It has a very sound scientific platform or foundation to further do some more research. Okay. All right, so I always kind of start with this idea that systems thinking is allowing you to see the big elephant, right? This is probably, most of you have seen this, where they're making fun of the scientists who are wearing their own coats, but they're blinded by their own discipline. And so again, the effort is that systems thinking is enabling that collaboration across different sciences. Now, just a quick thing about systems. Systems thinking does not mean, for example, it's not simply a collection of parts. What is a system? It's not simply a collection of parts. For example, if you see this image of bunch of utensils put together in a kitchen. No, that's not a system. A system has an organized system, organized framework, and an order in which all the things have to come together. That's an important part of what a system is. Again, this is, for example, a fuel system. An argument here is that a system can have several subsystems inside. Okay. Now, a few things about systems property from a more operational perspective. Generally, when we are looking at a system has a purpose. Finding the purposes actually becomes really important. All parts of the system are necessary to come together for an optimal behavior or performance of the system. If you change the order and arrangement of the system components, the system may not perform well. And two of the things that I wanted to highlight here is a system generally maintains a certain level of stability. That's a key, at least from an engineering systems perspective, I can argue. And that it is important for us to identify what is the purpose of the system. Now, I'm slowly kind of entering the idea of what is the purpose of a system from a systems thinking perspective for problem solving. Now, for example, a digestive system has a purpose to digest the food. An aviation plane has the goal or purpose to move from one place to the other in air. Knowing that is an important way for systems thinking and problem solving. A couple of more things. Systems have feedbacks. Feedback mechanisms are actually pretty key to system stability and system performance. In fact, the dynamic of a system is often between these feedbacks. What does a feedback mean? Sometimes they're self-enforcing, which means you keep doing the same thing, the intensity of the things keeps increasing. A good example would be, let's say, the viral load that a body has to deal with. If you do not provide medicine, the virus keeps multiplying and increases and creates a huge trouble for the body, right? Similarly, systems have balancing feedbacks, which means if things are going too much, there are controlling mechanisms to bring and stabilize the system. I'll give you an example. Here is a good example of body temperature. Human body, nicely kind of calm at 38 degrees or 36 degrees. If it's too hot, you perspire. And when you perspire, the temperature comes down. You bring it back to the same temperature. If you're too cold, your body starts to shiver. By the shivering, you start to gain heat, and the body comes back to that temperature. These are balancing or negative feedback mechanisms. So important thing for us to remember is systems have balancing feedbacks. These feedbacks, by the way, are available across the world. Some of these are, if you, unlike some of the discussion right now that's happening in the alumni chat groups, if you believe in climate change, then here are some examples of, gosh, I have to still say that if you believe in climate change, that says something. But there are feedbacks that are around the planet, and you will find this across the world, or in every system that we see. All right. So this was again a rapid thing. So what? Systems have a structure, systems have a purpose and goal, systems have feedbacks. And if you want to solve a complex problem, you must identify key components. You need to understand how those components are connected, how those connection and structure changes the way system works. And finally, understand, the 30,000 foot view, understand how the system is moving as a whole. Now, this is exactly the kind of nuts and bolts that we will talk about in the next session. So I'll stop here. Rapid information, but thank you. Sheila, I'll pause for your comments and reflection.
Yeah, I think that was a great summary and overview. So I think you have touched upon all the points. I mean, I think the main points that you brought in the second sort of part of the presentation, I would just reiterate one or two of those points that that there's a difference between a system and a collection. And just putting together some things together doesn't make it a system. It has to interact. It has to have a specific purpose, and I think Alark has given great examples. And again, he's mentioned that the socio-ecological systems that many of us deal with are more complex than the physicals or mechanical sort of systems. And they're in fact, one of the interesting things is that what you mentioned, their purpose itself may change over a period of time. And I really like the concept that earlier you had touched upon of the emergence. Maybe that's a very interesting sort of concept. So I think with this fairly quick but I think comprehensive overview, I think we can move to the next phase. I think we have I think time till 11:15, and we are at 10:54. So I think will give us ample time just to, in the end, we can have some reflections. Unless if somebody has really some burning clarification, just then they can ask now. Otherwise, we move to the next sort of part.
Great. Please keep the comments coming in, and Sushil can chime in if you see it's important. All right. So if you all are ready for the next, I guess it's not going to be 30 minutes, but let's just say this is how we operationalize the systems thinking. So as a start, I'm going to quickly say how I did it. For example, some of my work is around livelihoods of rural communities. And I wanted to figure out these are the different ways in which households earn income. And for me to learn about how they were making money or how they were surviving and sustaining, I had to interact a lot of, with a lot of different people to understand. And that kind of highlights important thing. You cannot by yourself completely understand a system and its components. It is really important to interact with folks, both resident and people who are engaged and living that life, and also probably people who have potentially an ability to think through the 30,000 foot view. But as a way to start thinking and describing a system, it is important to consult, and it is not a one-person job. So here is an exercise that I wanted to talk about. How would you go about trying to articulate what system you're dealing with? And so think about the scale, the spatial scale, the temporal scale, the political and administrative scales. Think about the social components, ecological components, political components, institutional components, name it, right? And so if you are interested in this, I would say, here is an example, and I will show you, but I will then ask you to do a quick 2 minute, let's say, let's take 2 minutes or 3 minutes to jot down across these different headings. And I'd sent out, at least requested, if you are dealing with a problem right now that you want to kind of analyze, here is a way to think about it. What is the scale of the system, and what are the different social, political, institutional, cultural, abiotic, biotic, and physical, that is infrastructure components that you can list down quickly, right? And the idea is to be very, very specific. Now, in my condition, I was basically, as a way to kind of think about what are these different components in my site, I just went to this kind of, age-old livelihood framework. But, fairly, actually, I was very impressed, that they actually had a pretty systems approach to thinking about it. And here in this kind of hexagon, as you say, I kind of use this as a way to describe my system. Here is a clear description. I'm describing everything from agroclimatic zones and forest types, land quality, to what the households look like. And here is a scale. I was thinking about this household and this village scale for about 100 years. That's, again, interpretive. It's my choice to figure out what's the time. Spatial scale, the panchayat, development scale, the block, political scale, the district kind of constituency, and ecological scale. You use the watershed. So here is a way, and I wanted to say, let's see, maybe give yourself 2 minutes to just kind of think through and whatever problem you're dealing with, and try to imagine what are the scales that you would like to incorporate in your system.
Okay.
And
yeah, so just to clarify, the people are expected to jot it down in their own notebooks, right? Not on the poll.
Yes, not in the chat. Thank you.
Okay, yeah, fine.
Yeah.
So yeah, people can take maybe a couple of minutes, I think, will or so. Then I think we can resume.
Yeah. And again, the idea is these are just general kind of, you may have other ways in which you want to classify components. This is a general approach. You may be the expert of your particular issue, and you may want to add more or not add more, depending on you. So it's an idea of first, kind of in terms of problem solving, is to first define what a system is. And the definition of the system starts with what is a scale and what are these broad components that you deal with. Okay. Okay. Sorry.
So yeah, so we'll take another minute or so for people to jot down their thoughts in their own sort of notebooks or devices, and then we'll, I think then you can continue, like after a minute or so.
Perfect. I see many recognizable names. Great to see all of them here. Welcome. Right. Shall we?
Yeah, I think Shubham has raised his hand. So is there a query?
Yeah.
Please go ahead. Please go ahead with your query. You can speak if you want.
Okay.
I don't know.
No worries, Shivam. If you want to type it in, that would be fine too.
Yeah, just do it.
All right. So I guess, so first, again, as a part of problem solving, the first thing is to describe a system based on its scale and the different components that you can think about. And as you are engaging in a problem solving effort, the idea is to be more specific. The more specific you can be, the better it is. Now, I'll move on to the next one. The next idea for problem solving is to actually imagine how these system components are connected. So if you have listed down some of those broad components, imagine, or even just use a a rough diagram and start to connect how those different components are connected to each other. Now, I'll give you an example here. Literally, this is, I sat down and quickly started to sketch. For my livelihoods diagram, I started to put these components in together. So the central image is, the money that the household is earning, but it is connected to migration. Migration is connected to industries and urban areas. Similarly, money is connected to forest, non-timber forest products, which is connected to forest policies, which is connected to the quality of the forest. So as you see, this is kind of a starting of a different set of components that are coming in, and I'm trying to make a connection between these two. Now, if this was a class that I was teaching for a full semester, we will spend 2 weeks on these diagrams, trying to think about and kind of recognize. This is kind of one of the things that I work on, but it invariably ends up in kind of a system structure. I don't want to scare you with this, but the idea is that you can develop a very well thought out diagram that shows a very clear relationship between ecological components, economic components, policies, institutions, etc. Now remember, I'm just going to take you back to the sustainability argument, that the foundation of sustainability efforts was to look at the relationships between social, ecological, or the diverse components. And so as you list these different components and you start to make those connections, those relationships start to emerge out. And that's kind of very important if a team is working together to say, oh, these are the relationships, and some of the relationships you would know, and other relationships will start to emerge, which is a really important part. Now, imagine also that when you start to connect these components, and I'm going to take an even rougher diagram. When you start to connect these components, the system structure starts to emerge. And that structure is actually very key for the next exercise or for problem solving. Because what we don't know often is, how is the system working? We have vague ideas, but not always clear. And I want to point out one more thing here. If you're looking at the image, this rough diagram here, look at the components that are the most. So there are some components that have 1 or 2 connections, and there are other components that have several connections. So the key for problem solving is to start identifying those components that have a high density of connection. A high density of connection essentially means those are the components that have the most influence on the system. Okay, so let's maybe let's say maybe spend 1 or 2 minutes again to think about, can you make those connections? I'm not sure, considering that everybody is quiet, if this is working or not for you all.
Yeah, if there are any, you need any clarification, please do, chime in. And otherwise, I think just take a couple of minutes to do this part, because it's very interesting. Like when you apply it to a practical problem that you are aware of and you're dealing with, then I think the whole thing becomes more meaningful, the theory.
That's right.
Okay, there's a comment in the chat that that system thinking can become input for design thinking and later can humanize system thinking. Okay. All right. That's
yes. Thank you, Rohit, for bringing that point. And in my course on systems, and I'm literally teaching this course where the system thinking then translates to design thinking. But I imagine that in this 75 minutes, it would be very hard to cover all the different kinds of thinkings that are going on. So I'm trying to give kind of at least here, a foundation of what the system thinking is. And then if there are more people interested, very happy to engage with that in the design thinking as well.
yeah.
But I think to Rohit's point, I think it's really important to recognize that this is it's a thinking process, and I think while there is pretty solid science behind it, for many of us who are practitioners in the field, the idea is to kind of create this systematic approach of thinking, right? And it's very, I mean, to be honest, you can really do it very conveniently once you know simple steps, right? Okay. In this idea of system components, I would have asked you if you have found these high density components, which means they have very high connections, then the next step for problem solving is then to look at that particular component and what is their historical behavior. So let's say, for example, I'm going to go back to my diagram here. Let's assume that agriculture has a lot of connections here. And so then I would want to see over the last 20, 30 years, whether there is what is the trend of agriculture, and I can use any proxy, whether agriculture productivity is increasing or it is stable or the productivity is declining, right? So one of the key things about systems thinking and problem solving is to start looking at behavior over time. And behavior over time of what? Behavior over time of system components. For example, you can do it for almost all of those components that are shown here, but you can think about behavior over time, for example, here of agriculture, behavior over time of how markets are behaving, behavior over time in terms of migration dynamics. And so you start to look at the internal behavior of system components in such a way that you say, oh, if markets are improving and agriculture productivity is improving, then clearly there is an upward movement or a positive movement in these combinations. But there could be a policy that might be going down, right? So behavior over time of system components is quite important for learning how the system is going to behave overall. Okay. So, so again, not knowing how if this is helpful, I would basically say that these are the steps that we'll put together. That's a great question.
There's from Jaisal, there's a question. How do we set a scope to limit the connections between system components?
Very good question. And I think the two-part answer is this. One, at some point you will feel like these, that, it's like the, let me just say, the paralysis of analysis. How much more do you want to keep connecting? So the important thing is this is where it becomes a little bit of an art, in the sense that have you found the important connections that you think are important within you and your group? The other way is to say that can you essentially describe the system by the number of components that you have connected? If you can, then that is sufficient. Does that help? I hope that helps.
Yeah, thanks. So there's another one by Prabhat. So, it's an interesting question. It says, do systems create institutional inertia? So like basically, and he's giving this example of UN or like broader sort of international systems. Then how do we bring about change?
Great question, Prabhat. And I think, yes, systems can, if we use the complex adaptive systems argument, then systems have a capacity to create institutions. Institution is in itself an emergent phenomena, and to know whether that emergent phenomena is actually going to drag or slow down the system or to accelerate, it depends really. But that a system can produce such institutions. And to your second point, how do you reduce that inertia? I think the point is actually first to even know what the goal of the bureaucracy, for example, in UN is. And if bureaucracy is, the same thing that produces stability is also the same thing that produces inertia, right? And so in that sense, the idea is to recognize the goal of the system. And in management, at least in the places that we worked in, often the bureaucracy that has been created, the goal of the bureaucracy ends up being creating stability rather than high performance, etc. And that leads to a reduction in the performance, right? So learning what the system behavior is and the goal is actually really helpful. Okay. I feel like a couple of more comments had dropped in, Sushil.
Yeah. So Shailesh is raising this point about scale and purpose of a system, and I think and he's saying that it's a function of our sort of or the institution's values. So which is what is at the core of an iceberg. I think it's referring to the iceberg model.
Perfect. Yes.
Yeah. And you want to take that first, and then there's one by Manmeet.
I think I'll take Manmeet's one because I have the iceberg model again, so I will probably go over it and I'll be curious what people think. Yeah.
All right. So if, I mean, her question is that if local politics is part of my system and we want to describe change or movement in this subsystem in a given time, how do we do that? We all
So,
understand political systems
mhm.
are complex and slow moving. Yeah.
Well,
Yeah. So,
that's a great question. And of course, the first thing is actually that even the ability that you have brought in political component inside your system in itself is actually very, very observant. Often when we are doing analysis, the politics or the power issues are often left out, partly because people don't know enough or it is too complex. So that's one. The second, though, is I wouldn't broadly generalize that political systems are slow moving or not. I think the point is that you have to see whether your specific political component has performed slow or fast, or it could be a variable. But that depends upon, you have to look back and see whether the system has always been slow and it will not respond, or has it been recently slow? And that's the question of kind of the historical trend that you want to analyze. So I would say put that perspective in. And I forget the last part.
yeah. No, that was on that same thing. But I just want to add that yeah, I agree with you. The political systems can move very fast if there is a strong political will on certain matters, and
Right.
as we can also see, it depends on whether the particular issue resonates with the and aligns with the priorities of the political system that you're dealing with. So it may
Right.
not always be slow moving. Yes, it's complex, but it depends, I think. Yeah.
Exactly. Yeah.
Okay.
Perfect. Okay. So I think
Yeah, please.
is there more happy
No,
to
no,
take
there
any
are
other.
no comments. You can, yeah, move it. Yeah.
So I think so glad that the iceberg model has been brought up, because by the way, there is, again, I teach this course for an entire semester, so trying to pack everything in this was just not possible. But I think we have these three big components, topics actually are really useful for you to start. And of course, I'm assuming that many of us are familiar with iceberg, but for sake of everybody's kind of coming to speed, the iceberg model is often the idea that at the top, we're often looking at events, but that those events, what we see, whether it is pollution or a mining disaster or a kind of fire in the southwestern United States, all of those are events, but that those events have a huge kind of structure and background that we must analyze as part of problem solving. And so the reason when I asked you to first go through system components and connect those components for structure, I'll tell you where they become useful. The first thing from an iceberg model is that whenever we look at an issue, we always want to see what is the behavior over time. For example, let's just say pollution in Delhi. What has this trend across the last 10, 20, 30, whatever your scale is? Has that trend been similar, or has it been different, right? So an event is a starting point, but it's not the end point for analysis. The event helps us analyze what is the behavior over time of the same issue. But then, as you see in the layers of the iceberg, the important part is that if you are seeing a certain behavior over time, for example, one can say, well, there's always been such kind of pollution in Delhi. Okay. Well, what structure is causing that behavior over time? And the argument here basically is that the system structure produces the behavior. And what you're seeing is just one event of that behavior over time. So knowing the structure becomes really important. And then finally, in the bottom, which is at the core, is that the mental model, which is the visions, the values that have created the structure, really influence the entire iceberg, or both the events and the behavior over time. So when we talk about systems thinking and problem solving, the idea then, and here, the idea is that the mental models and the dominant values create a structure. The structure then creates processes that lead to the behavior over time. And finally, that behavior of time is leading to the topmost, which is the events that we often see as the most obvious, right? So it's an important thing from a iceberg model, and I believe you have. And I put this rather quickly, but I hope you would follow this. That if let's say we think about how do we use this, right? Let's say the event was the Galwan Valley skirmish between India and China. Now, is that a single event or is that a pattern? And so when we start looking at the pattern, we are seeing that there was an increased frequency of border disputes between the two countries, right? So that's the behavior over time. Then what is causing that behavior over time? So I've kind of put this rather, kind of in a quick way, that there are issues of unfinished unmarked borders, past wars, political systems that are different, the growth trajectories that these two countries have, and the the resource related competition that's happening, strong armies and high national values, right? That's combining the system structure, which is causing this behavior over time. And what are the dominant values and the mental models that are underlying these system structures? And so, this is my take on it quickly, but this could be, sovereignty is a dominant value. Mistrust by itself is a dominant value, or hatred towards each other. Or the dominant value could be opportunism to rather quickly cash on to some of these things. Now, again, this is a quick and dirty kind of an example that I wanted to create as a way to say, okay, what do these mean? But hopefully that explains where these connections are, right? Okay. I saw a bunch of comments coming in, Sushil. Should I take them or?
Sorry, I was on mute. Yeah, so please, if you are, so rather than me repeating, I think we are a little bit all at time. So maybe, just go and address
okay.
them.
Does the iceberg model also suggest that most sustainable shift in outcomes will come through the changes in mental models or our values? 100%, absolutely. Iceberg model, and not just iceberg model. In fact, if you do root cause analysis, or even if you talk about the literature currently around transformation, almost invariably everyone talks about how we need to change our mental models about resource consumption or what is a good life, etc. So it is if we can change those mental models, that is the biggest transition. However, it is also the hardest one to bring, I would say. Yeah. Go ahead.
There's also this question about the boundaries. I think that's the point, like what is in our control. Even when we do theories of change and things like that, we put a boundary, right? There is something which is beyond, our sort of, zone of sort of influence or impact. I think that's something we should be aware of in all. But yeah, that's a very good question. Like, I think you may want to take it up on the boundary of the system, because system, as you said, you can look at Bhopal, then you can also look at it as broader subcontinent and things. Yeah,
right.
Please.
So I think there are two parts to it. One is to know what is the zone of influence, as Sushil rightly pointed out, which is very important because that's where we can influence and do our efforts. But I think the point of boundary is to then recognize what are the outside influences that are about to come inside. So the way I want to say about providing the boundary is not simply to say, well, this is outside our analysis, so we cannot talk about it. In fact, it's the other way around. I would say that once you put the boundary, you start recognizing as those forces that will influence us, but we don't have control over. It doesn't mean that they should not be part of the analysis. It actually means just that we won't be able to influence them. But it actually may have a very dramatic effect on the system's behavior. So I would always say boundary is always a great question. In fact, the hardest one, as we kind of put students to task. Where is your boundary, and how do you come up with that boundary? It's literally, how much efforts you have and how much capacity you have to kind of even think about that. So it's almost like an art to figure out what the boundary is really. Yeah.
Okay. There's a very interesting one by Prabhat about the mental models and the allure of conspiracy theories and so on.
Oh gosh.
A little bit. That's a broader question than this. Yeah.
What mental models do you think underpin the allure of conspiracy theories and such mindset? Is it tribalism, and to what learned over evolution, or is it more recent to alternate facts? We are going into kind of we are working on something called knowledge, attitudes, and practices that directly connects to Prabhat, your question. That, for example, you can provide, 15% of United States population, you can give any sort of information on climate change, and they will completely reject it. Is that a mental model? Maybe the mental model is to distrust scientific information, to distrust authority. Tribalism, I mean, I think it's not A versus the, I would say probably a blend of all of it. So I don't have a very good answer for it. But I do think
I mean, that's a very broader sort of question. But yeah, it's actually certainly makes us think. This is a very good, I think, we are coming to a close of the class, but it's good to recognize that actually underlying all this, there are these mental models which are difficult to change. They kind of form over a long period of time, and for actually change, we need to understand them at least, and try to address them. So yeah, it's a a great way. So Alark, I think we are almost at time. So I don't know how. Do you have a few more slides? We can go on.
I think we are done. I wanted to say that actually, just to recognize the leverage potential, if you're trying to deal it at events, if you're trying to solve the problem at an event level, then it doesn't have that leverage, or you won't be able to change much. If you really want to bring the biggest change, often it is at the mental model level. We discussed this, but actually, this is where, at middle level and senior level management, this is where you have to evaluate how far can we go and how much resources do we have. Like, changing mental models, as Sushila has rightly pointed out, could actually take 25, 30, 40 years. And sometimes, although actually have happened fast. For example, United States, once it came to it, the smoking cigarette as a really kind of huge shift happened rather within the 5 years. So, but you need to know where the system is and how fast you can change. So, anyways, leverage increases as you go down, and it's often, this is where, how do you create a great vision, what values you use, is very important for system thinking. Okay, so I think, what are the key takeaways from system thinking? It enables holistic analysis, systems components, their relationships, the processes, and of course the overall system. I actually personally really enjoy systems thinking because it is a great space for collaboration. It is a place that really enables ecologists to talk to economists, who can talk to anthropologists, who can talk to somebody else, right? It really helps in creating a common platform for problem solving. And I can say for sure, if you want to still be competitive in the world of AI, this is the thinking that you must embrace. All right. So I will pause here. I will not take any question, but here is my kind of thing, that this was the picture that said the presentation is done.
Wow,
Thank you for
great.
listening to me.
Yeah, thanks so much, Alark. So it was great, I think, overview of the systems thinking, as well as the practical ways in which it can be applied. So we are almost out of time, but I would just see if anybody has any other burning sort of questions. Then we can have a 5-minute sort of discussion. I think Shailesh has raised a hand.
Yeah.
Yeah, please, Shailesh, go ahead.
No. I think it was a mistake. I just wanted to react. That's it.
All right. Okay,
Thanks.
fine.
Thanks
No
a lot.
problem.
This was very, very interesting and
Yeah,
useful.
and also, yeah, thanks. I think, Jose, you've been listening patiently also. Great. So I think a lot of discussion has happened towards the end of presentation also.
Right.
And so maybe we can complete. Okay, so Shubham has raised a hand. Shubham, you have a question or a comment? Or was it also by mistake? Okay, I think it might have been like by mistake only. So I think thanks, Alark. I think it was a great presentation. I think the Alumni Association will share a PDF version of the presentation with everybody. And my request is, Alark, if you have maybe a list of further readings or something which you may be giving to your students, if you can also circulate that, because I think it's better, that kind of people, if they want to go deeper in the subject, it's always good to go and read. So I'll not take a lot of time, but just I think you've used that paper from Kim 1999. I saw that. So this was a paper that was used in one of our internal trainings also a couple of years back, because we also have a team that does this sort of trainings periodically. We go
Right.
through. So so that actually there was a training on systems training we underwent a couple of years back. So there, actually in that paper, I found an example which clarified for me at least a lot of these things that you have also mentioned, and you have clarified with the China example and others. But there was a very simple example from, I would say, the industrial or organizational setting, which I really like. It's very simple. So there, in the iceberg model, the event was that there were a lot of products that were coming from the assembly line as defective. That's the event that you're having. It's there in that paper. And so they are the defective products. And when they analyzed the pattern, it was that when a lot of these defects happen when the shifts change, when the one shift ends and the next shift starts. So the pattern was clearly telling that something is happening at the shift change that's leading to a lot of defects in these products. And the systemic structure that was found was that there was no overlap between the incoming crews and the outgoing crews. They did not interact with each other. There was no overlap. And the mental model was, if I remember correctly, was that the workers thought that they are responsible for only what happens within their shift.
That's
they're
right.
not responsible for what happens in the second shift. They're not responsible for the product quality overall. They're responsible for their shift. And then actually they added another layer, which I don't know whether the trainers that were telling us or it's in the paper, I don't recall, but they said that it underlined, even the mental models had this sort of broader vision, which said that there's a competition between different crews for who does the best quality work. So everybody trying to do their best quality work themselves, sort of competing with each other, was resulting in defective products being faced because they actually need to cooperate. So I suddenly recalled when I saw that example which was given. It's kind of explained the iceberg very nicely. Anyway, so I think it was great session. Thank you so much. Thanks to everyone for taking time on the first to Alark for giving a part of his evening. I think, as they said, the greatest gift is the gift of time that we can give to each other. And similarly for everyone who has taken time from the Sunday morning to come in and participate in this alumni session event. Thank you so much.
And thank you, Sushil and Alark, again on behalf of the association. Thank you very much for your time and this very, very great session. Amrita, let's make sure that the recording of this is available to everybody if they'd like to refresh. And then, yes, we'll circulate the PDF of the presentation as well. Thank you so much, everyone. Have a great Sunday. Thanks, Alark. Have a good night.
Thanks also to the Swapan and the team, Amrita and others who have organized it. Thank you so much.
Thank you, everyone. Really great. And I wish you a great Sunday. Thank you, Sushila, for such a great discussion. I thoroughly enjoyed it. Okay.
Thank you so much. Take care.
Bye, everyone.
Bye.